Right, so today we're getting into solving square root equations. Like most equations where you have some operation going on in there besides just addition, subtraction, multiplication, and division, the first step is really to isolate that part that isn't one of those basic function types. In this case, that means isolating the square root. So the first thing I want to do for that first problem then is add 4 to both sides. That way I've isolated the square root. Once I've isolated it, then I can get rid of it. So what is the opposite of a square root? That is, what can I do to a square root to make it go away? Yep, we square it. So I then square both sides of the equation. That is, raise both sides to the power of 2. And when I do that, it just cancels out the square root that was over the x. So now that's just an x. Whatever was inside stays exactly as it was. And now that equals 81, because I did the 9 squared. And since we have now x equals 81, we're done. Notice there's no special rules here, no funkiness, there's no plus or minus that we have to worry about here. If we introduce the square root ourselves, yes, we have to include plus or minus, but when it's already part of the original problem, it's only asking about the positive square root. Because that's technically what that symbol means, is the positive root of that number. All right, now taking a look at the second problem there. For this one, we again want to start by getting the square root isolated. We want it by itself. So the first thing we want to do is subtract the 3 from both sides. And then just like previously, now that I've isolated the square root, I want to square both sides. When I do that, all it does is cancel out that square root on the left. So now it's just x plus 5 equals the 16. The 16 because 4 squared. Now that my equation is just x plus 5 equals 16, I just move the 5 over. And so I subtract the 5 from both sides, get x equals, in this case x happens to equal 11. And that's our basic process for solving a square root equation. Not too tricky, at least at this point. There will be some trickiness that comes later, but we start with the fundamentals. Having seen those, you should be able to solve these. So again, try solving each of these on your own first, and then we'll see what they look like here together in a minute. So we've seen how we get these answers, but this last one actually has a little bit of a wrinkle to it. Because we did the algebra and we found that x equals 79. And yet, that actually doesn't work. If I plug that 79 back into the equation up here to check my answer, you notice that ends up giving me the square root of 81 equals a negative 9, because I had a negative 9 up here. Square roots always equal a positive number, right? The square root of 81 equals 9, not negative 9. There is no plus or minus in front of this square root to change that fact. And so because of that, because the left side does not equal the right side, we actually find in this case that there's no solution. And that's what we would write for our final answer, is no solution. And the way that you can know that, without even having to get to that point, is that anytime you see a square root equal to a negative number like this, a square root can never equal a negative, and therefore we can know at that point that there will be no solution. And so yes, that is your answer that you would write on your paper, is no solution. Then, 2 more for you to do and solve out. There's no new wrinkles in here, it's mainly just a matter of execution. Remember to isolate your square root first, then go from there. When I look at this, I just see 1/2 times the square root, and I got to get rid of the 1/2, so I'm seeing I got to divide by 1/2. Now I want to take a moment on this part of the process though, because it throws some people off at times. So when I do 4 divided by 1/2, well, remember, that means you actually have to do fraction division. Now the rule for dividing with a fraction, remember, is, well, in this case, first write both of them as fractions. So 4 becomes 4 over 1. But then we always multiply by the reciprocal. That is, the first fraction stays the same, but I flip the second fraction and change the division and multiplication. When I do that, I got 4 over 1 times 2 over 1, and then I multiply the fractions, which means multiplying straight across the top and straight across the bottom. And so you can see then that dividing by the 1/2 was the same as multiplying by 2, which also would have been a valid way to go about it at this point. Some people, instead of writing divide by 1/2 here, they will write times 2 on both sides. And as you can see, it gives us the same thing either way you think about it. So this is where you'd get in your work. All the detail was just to remind us why it ends up giving us 8. And so, then go ahead and finish it out from there using the same method. Alright, so final answer ends up being 56. Follows the same methods as we normally would go from there. Now that we've basically got this method down, just working with an x and the numbers, now we're ready to start pushing this up a level, start seeing some different variations that we got to worry about. So, we're now going to take a look at doing these 2 problems. Go ahead and write down that first. And for that first one, notice what's different about this compared to the previous problems we've done. This is not a square root. This is a cube root. That is the 3rd root. Just whatever numbers in here tells us that. So basically what that tells you is that when there's no number written in there, like the problem on the right side, it's assumed to be a 2 if we don't write it in. Hence the square root, the 2nd root. Alright, but in this case it's cube root. So if this is cube root, what do I do to it to get rid of the cube root? Cube it. Absolutely. And so I'm going to raise both sides to the power of 3. That is, I'm cubing both sides. And then once you've cubed both sides, it works the same way as all the other ones did. Alright, so we saw how with the first one worked. Once we cubed both sides, it was same as normal. The second one starts normal, but then needs a little bit new technique after that. On the second one, yes, we still start by isolating the square root. In this case, that means adding the x to both sides, and then I still get rid of the square root the same way. I go ahead and I square both sides of the equation. But now I have x plus 6 equals x squared, instead of equals a number. And that adds some complexity to this problem. So now, think of it like a whole new problem. I have x plus 6 equals x squared. That is, I have an equation that involves both x and x squared. When we've seen these in the past, and we have seen them in the past, we've always had them set equal to 0. And that would actually be the first thing I would do here, is I want to make this equal to 0. Because I have a quadratic that I'm going to try to factor. And so, if I'm going to set this equal to 0, and I know I'm going to be trying to factor it, I want to keep this x squared positive, because of course our factoring is easier when x squared is positive. So I'm going to move the x and the 6 to the right-hand side. So I'm going to go ahead and subtract x from both sides, and I'm going to subtract 6 from both sides. All right, and now that I have it set equal to 0, I have a quadratic. So that is x squared and the x in there. I'm going to try to factor it first. I sure hope it factors, because if it doesn't, I'm going to have to use quadratic formula. So I need to see, does it factor? Well, if it does, it's going to add to -1, and it's going to multiply to -6. Are there 2 numbers that add to -1 and multiply to -6?
Yes.
Yep. -3 and 2. And so I can factor it then into 0 equals x minus 3x plus 2, which remember I do so that I can actually figure out what x equals. I'm setting each of the parentheses individually equal to 0 and solving those. You should find here that x equals 3 and negative 2. And oh, if only that were it. There is actually going to be more to this problem. Whenever we see a problem like this, and we have an x that is both inside and outside the radical, we're going to need to check our solutions. Remember earlier how we had that one problem where it equaled negative 9? And that was impossible. Well, when you have the x on the outside here, that could be a positive, that could be a negative. If it's a negative, then we're not going to be able to do it. And so we actually have to check our solutions, and we check those solutions by plugging them back into the original equation. Always back into the original. Never into one of your later lines down here. It has to be the first line. So this line that you see over here that you're also adding on your paper there is where I'm checking x equals 3. So I plugged the 3 in for x wherever it appeared in the original equation. And you always plug into the original equation, just plug in one number at a time. And then all we're going to do is just figure out what each side equals. I'm not moving anything side to side. I'm not manipulating the equation. That might be what gets us into trouble in the first place. So I just want to figure out what does it equal. So then on the left side, the 3 plus 6 is 9. Then the square root of 9 is 3. And 3 minus 3 equals 0 on the left side. The right side was always 0. So I ended up with 0 equals 0. That is correct. 0 does equal 0. Therefore, that one checks out. 3 is a solution. Now I repeat the same process by plugging the negative 2 in and checking that. And so I go ahead and simplify on the left-hand side, never moving between sides, only simplifying within the same side. And notice I end up with 2 plus 2, which is 4, which does not equal 0. Therefore, that one did not work out. Now remember, that's what I got by plugging the negative 2 into the original. That means that the negative 2 over here is not really a solution. Only the 3 is a solution. That negative 2 is what we call an extraneous solution. An extraneous solution is an extra solution. That's where the word extraneous comes from. It starts with extra. It's an extra solution that does not actually work in the equation. And so remember the rule. Anytime you have x both inside of a square root and outside of a square root, after we found our solutions, we have to check both of the solutions, if there's 2, or basically all of the solutions, however many there are. And they're only actually a solution if they work when we check them. Last thing would be actually a little bit of notes. I mentioned extraneous solutions there. It'd be well worth putting in your notes so you remember what we're talking about as we keep talking about extraneous solutions going forward.